Welcome to Anatomy and Physiology. My name is Liz Zinker. I am also the lead lab instructor. You will also hear Sherry Zayo's name. She's the lead lecture instructor. We both switch off teaching 227 and 228. So typically I'll be doing 227 this semester. I'll be doing 228 next semester. If somebody needs to retake 227, they would end up taking it probably with Sherry next semester, that type of thing, and flip-flopping. Let's see. The first thing I'm going to do is I'm going to take you guys through to the website that we ask you guys to register on. The reason that we use this website and not just everything through Blackboard is because when the semester is over, you don't have access to the class anymore on Blackboard. Also, they'll be switching to Canvas in the next semester or so anyway. This website is hosted by Sherry Zayo, so she pays for this. And it's set up where even when you guys are done with A&P or you've left NIC and now you're in probably a healthcare field or going through one of the job fields in that sense, nursing, PA, physical therapy, something like that, they typically will go through anatomy and physiology, but they zip through it really fast. So what we cover in 2 semesters, they're covering in 6 weeks. So what we cover is a very good basis for you guys, and a lot of students will come back and review their notes or look at some of the old lectures, and it'll help prep them and help them feel a little more comfortable when they have to zip through it so fast in their other programs. So that's why Sherry created that website. If there's a problem, let's say you logged in and you are unfortunately seeing only 228 information and none of the 227 stuff, Sherry would be the one that you would email or message, and she will get that fixed. So she does everything with the website, but myself, Sherry, as well as the other lab instructors do respond on the forum posts that we put in there. So the website is niscienceclasses.org/CMSANP. So NI for North Idaho, science classes, so NI science classes, did I spell that right? .org/ and CMS stands for Content Management System, A, and the letter N is in Nancy, and then P, and it should take you to a login or registration page. So if you haven't gotten on it yet from the Welcome to A&P email, you'll click on Sign Up. Make sure that you follow the directions for the username, because if you don't follow the directions, in a week or 2, maybe a little longer, maybe later, Sherry will go through and purge the system of people that did not register properly. The proper way is to do first name dot last name. So don't put other initials and no dots and things like that. It will probably allow you to register now, but then at some point in the semester you'll say, I can't see any of the info. It won't let me log in. So follow the directions. A lot of A&P is following the directions. So you're going to log in. You make sure you use your NIC email only. With school stuff, we're supposed to keep everything through the NIC email accounts. When you register for Connect later, that came with your books, you need to use your NIC student email accounts also, okay? So then you would sign in. So I'm going to go ahead and sign in. And then so the main page, whenever you come in, oftentimes looks like this. And then you're going to log in. And then it's going to look like this. And what I highly suggest is that you click on the Welcome to A&P icon. So that way it will have different areas that, for example, will tell you how to navigate the website a little bit. You guys are going to feel awfully overwhelmed the first couple weeks or maybe more in A&P because it's a lot of material. We go through it pretty fast. And you're saying, oh, I got to go to the Connect website. I got to go to the A&P website. And it's frustrating and you just want to get through A&P. So this will help you do that. So read through the information. It kind of tells you what the different tabs are, where you can find things. You'll notice that if you have like a private message, so if you can PM or private message Sherry or myself or other students within the class. And then also, I see a little more than you guys. Most of you guys will just see 227 information, but you can click on these tabs here. And another way you could do it, you can always go back into the home page. You can go on resources, maybe, and you will have an area that says exam prep, which for 227 will be things that have to do with all exam tips, study guides, PDF exams, so you can look at old exams that are from years ago. You can practice on them. This is where you would go to find your exam keys after you've taken the exam, not the current one. And what we suggest is when you are done taking an exam and we post an exam key for you to view, you need to print it off and then go back through your exam. Usually what we suggest is that you go back through the exam without seeing what the right answers are and see if you get the same answer. And I'll talk about this again when it gets close to testing time, because sometimes people will have a little bit of test anxiety. And if you get a better exam outside, better score outside of that exam environment, it probably meant you had some test anxiety and you second guessed yourself and you messed yourself up. But if you get the same things wrong, it means you didn't know the material. And that's a wake-up call. Don't wait for the third exam or the fourth exam to change your study habits. I'm going to give you tips as we go along the way. This is how I would study this so that you guys can get an awesome grade and not have to struggle through and slog through it. So we'll talk more about exams later. But the other thing after exam prep, you're going to see lab preparation. And you're going to see 227 lab news. This tells you exactly what to expect for lab of that week. So for the first week, you click on it, and it's going to tell you what you guys are going to do this Thursday and Friday when you come to lab. And we don't expect, especially in 227, that you will have done any of this stuff before you walk in the door. But for those of you who kind of knew somebody else, or some of you may be retaking, it's a little different than the old book that we were on, because last semester and this semester we switched over to a new book. So this is what your lab manual looks like, Anatomy and Physiology, with the 2E and the guy in the wheelchair and racing, okay? And you had the option to either get a hard textbook with the Spiral Lab manual and a Connect card, or you have an option to get the e-textbook with the lab manual and the little Connect card. And it's in lab that you will figure out how to get into the Connect stuff. So that's why we didn't, we're kind of fielding your questions like, don't worry, wait till lab, wait. We want to get you guys all on the same page so it's a smooth experience getting logged in. So your first day of lab, you're going to meet up in the lab, and they're going to take you down to our computer lab, which is on this floor, on the first floor, and we're going to walk you through and get you into Connect in the correct section. So don't stress, okay? But bring your registration cards with you. If you're waiting for financial aid, or you haven't purchased the books yet, or you're just kind of waiting a little bit, you might want to get it before you come to lab that day, or you can get on as a courtesy access for just shy of, for about 2 weeks, and then it will kick you off if you haven't purchased the material and register again with your card, that little cardboard pieces. So don't throw those cardboard cards away that come in your book bundle. So you would read through lab news. You would do this before you would have come to lab typically, and it tells you what you include, what you omit, what's for information, what to expect. And your lab instructors are going to go through all this lab stuff with you guys. So don't stress, wait till lab. It's only in another day or so. But that's what lab news is all about. So now you know where to find that in resources. Another thing that you may want to do is you can go into lab articles and then here's cat dissection photos and Google images. So that welcome letter I sent out was kind of get familiar with the website. Play around, click around in a couple places, get yourself a little bit familiar. Under lab PDF documents, this is actually where we will register you into Connect, which is this first page right here. The second one is for 228, so don't click on that one, you'll get into the wrong section. But you'll know you're in 227 because the second link down there for the lab portion says 227. You have to register both first in the lecture section, which is number 1, and then you do the URL for the second one, which is number 2. But just wait until lab. It'll be so much easier. It'll give you something to do in lab anyway. Okay? So, but this was in case I know a couple of people were sick. The flu's going around. So lab documents, you can find stuff in there. Another thing too is when you go to get into Connect later, and your lab instructor is going to walk you through this, you also go into a link down here for Connect. Okay? You can also get to your Blackboard account there. This right here is the YouTube channel. So it's a private channel. Only you guys that have logged in will know how to get to this channel and see things. And this is where when I record these lectures and I post them, you can go in and listen to them later if you didn't catch something with notes, or you were sick, or you didn't get that concept and you want to go back and hear it again, or internet students are hearing it through this venue as well. And there are some complete chapter videos in there, but they're based on the old text, but the information doesn't change a whole lot from semester to semester and book to book. It's all same information, and the voice that you hear on those videos are Peter Zayo. He used to teach here. And let's see what else. 227 grades, so when grades get posted for midterms and right before the final after your exam 5, this is where you would go to look at your grade. The rest of your grades will be in your Blackboard account, so you can kind of monitor how you've been doing with some of your grades there. And then the curve is something to click on, so we do use a curve in this class. If people are doing phenomenal in the class and getting 100 on stuff, then is there a curve? No. But typically, it's not easy getting an A, right? With my squeaky voice, it's not easy. But A&P is a difficult class. Okay, it's definitely possible. We do get students that get A's. The curve isn't going to affect or help a whole lot that person that's on an A or a solid B, okay? But it helps people that are right on the cusp. And it's not going to help somebody that's consistently failing exams. If you're getting 20s and 30s and 40s on exams, you're not miraculously going to have a C or a B in the class, okay? So at the end of the semester, I get everybody going, but please, the curve has got to help me, right? No, it doesn't help that much. It's not a miracle, all right? For those of you in the face-to-face lecture, you also have the opportunity to do a clicker bonus, okay? So that looks like this little device here. What you need to do is you need to click on clicker bonus, and it will give you the rules and regulations. You need to read through that, because if you are posting information about clicker questions, if you are cheating, if you're blogging, if you're doing whatever, anything that is a violation of the etiquette, then you get removed and you don't get that opportunity. You get upwards of, I think it's about 37 to 39 extra credit points, potentially. So there's way more clicker questions than that, and then I randomly pull the questions. I don't look at, oh, they got that one wrong, I'm going to take that one. I don't do that. I just randomly pull the various dates, and then it just gets uploaded. So if you're consistently getting them correct, then you're probably going to have close to that 40 points of extra credit by the end of the semester. We do the same thing in 228. You can rent these. So if you go to the bookstore, you can see about renting, and you might find some cheaper options. You just have to be on channel 41, and you have to sign up for it. One, you're saying that I will abide by these rules. And if somebody wants to be really snarky about it and say, well, she is mean and I don't want to play her rules, then we just take clicker points away and nobody gets them, and that really sucks. So be nice, play by the rules, and when you just follow the directions on the actual code that you log in, because there's like an ID code, there's like 5 million numbers back here, so just make sure you're putting the correct serial number into it. And it will log you in if you had it incorrect, but at some point, Sherry will load up these points, and you'll see it on the site, and you'll be like, well, how come I have no clicker points? I've been doing it. And then Sherry and I will post a thing saying, if you can't find any clicker points, you'll need to go see Sherry. And you'll have to take your student ID and your clicker and go to Sherry, and she'll give you the stern look of, you didn't follow directions. You're going to hear that a lot in this semester. Not for me necessarily, but your lab instructors probably. So that's clickers. Let's see. Also, you'll find like your cap photo albums. Lab instructors will go through that some more. The other thing that you'll notice, we encourage you guys to ask questions. So there'll be general announcements. So right now there isn't a general announcement. If there's a new announcement, it'll have like a little green new next to it. So if you're seeing a lot of new things on yours, you should start clicking on them and reading up. Typically, somebody will ask a question. I or Sherry or one of the other lab instructors will post an answer. Or another student might post an answer, which is awesome. That's what we want you guys to do. And then somebody else will ask the exact same question. And then I'll get snarky and I'll say, did you read the other post? Because do you know how annoying it is to repeat the same answer over and over and over? And it's really nice when you guys post on the website and not just email me. Because then other people can see it. Because I guarantee if you have the question, probably half the class has the same question. Okay? So I encourage you guys to use the forum posts. And you guys can answer each other on the forum posts. It doesn't have to be another instructor. If you're giving the right answer, another instructor is probably going to be like, thank you. And they'll give the little thumbs up icon on there so you know, yeah, the instructor verified that too, so we're good to go. You guys shouldn't and wouldn't see typically the 228 posts, but you should be able to see the 227 posts. So if for some reason you're not seeing the correct information in here, you just email or PM Sherry and she will get you into the right part. Other things, so we have our course policies here. That's the new word for syllabus. So in Blackboard, you'll see your syllabus and also in here. By the way, if you are an internet student that happens to be in here today or you are just listening to the recording, internet students do not use these physical clickers. They have a separate way through Blackboard that they answer clicker questions, but they do not need a clicker. So if you purchased one or you rented one, turn it back in if you are an internet student. Okay, so you guys don't have that option as a face-to-face student. So if you go into course policies, for the most part, I want you guys to read through this yourself, but if you're trying to look for me or some of the other lab instructors, all of our names and contact info is there. It gives you the book information here. I think the link, anyway, the link might be right or wrong. I can't remember. Your points in lab and lecture are combined, okay? The majority of your points in your grade comes from lecture. So where do you want to spend most of your time? Focusing on the content for lecture. Okay, that's 2/3 of your point. So it's 5 total exams, each 100 points each. There is a 6th exam. So if you have emailed me already or you are potentially going to email me saying, I am going to be absent for this because our family's taking a trip or I'm going somewhere or whatever, there is no makeups for exams. We don't have a second section for you guys to show up and try to make it up in another section. If you miss an exam day, and they're already posted in the schedule, if you miss an exam, that's what exam 6 is for. So you would get a 0 on whichever one you missed, and exam 6 would end up replacing it because it's the top 5 exam scores. Exam 6 is during finals week. If you were here for all 5 exams, and you could be amazingly happy with your grade and everything is wonderful and perfect, you don't have to take exam 6. That would be the 0, and that would be the grade that's dropped. If you want to improve one of your grades, so you're trucking along, but you were sick on one of the exams, and then you decide, okay, I really bombed that exam, so let's say you accidentally got that 20 or 30 or 40 on an exam, or maybe it's a 60 or whatever it is, exam 6, if it's higher than that score, it will replace it. And that one's the one that gets dropped, okay? To me, it would behoove you to take exam 6 anyway, and guess what? Exam 6 is a combination of 10 questions from each of the first 5 exams. So you have all of the answers because you will have had all of the answer keys. So you could get 100% on exam 6. What we suggest is after exam 1 is done, go through and figure out, where did you make your mistakes? Did you just not read carefully? Did you have test anxiety? Whatever it is. And then learn from it. Then go back through and start memorizing those 50 questions. They will be identical, randomly pulled from exam 1. And then you'll get exam 2. Same thing. Start memorizing exam 1 and exam 2. We're going to pull 10 of those questions. And I don't pull those questions until the very end of the semester. That way also, if there was for some reason a mistake on an exam, I'm not going to pull one that had some issues with it, obviously, because that wouldn't be fair to you guys. So identical questions, exam 6, you already know all the answers. You know the questions, you know the answers. It might be jumbled up order-wise, obviously, but so I highly recommend take exam 6. The worst it could do is be the one that gets dropped, right? And don't assume that, well, I'll just miss this one anyway, and I just will expect exam 6 to do it, because what if you get sick again? That really sucks. Okay. So, let's see. So I talked about missing a lecture exam, attending labs. They'll go over the lab stuff more with you when you're in there. Participation points, that's kind of, be in lab, basically. Lab quizzes, they'll talk to you about that in lab. Missing a lab, they'll talk about that there. Your notebook, they'll talk about that in there. Okay. Lab practical is 100 points. That is not an exam that you can drop, okay? So you have 500 points from lecture, 100 points, let me pull it up here this way. Here's our grades. Okay, so lecture you have 500 points in lecture exams, right? The lab practical you have 100 points. Lab evals are approximately 45 points. So you have some evals in lab that'll be 5 points, some will be 10 points. You have a big one at the end that's 20 points. Quizzes are about 5 each, so there's probably going to be about 4 quizzes. That occurs in lab, not lecture. Notebook checks, this occurs in lab also. Those are 5 points each at 3 checks. And general participation has to do with lab also. So that's all lab stuff. Pre-labs and fills all have to do with lab. They're going to talk to you about that there. So as you can see, out of the 725 points, 500 of them are from here, and only 225 are from lab. Okay, so they're going to talk to you about creating your lab notebook and everything, and you don't have to be an artist, and you don't have to pour hours and hours and hours into your lab notebook, okay? Use your brain power for the information in here. You won't realize it yet, but what you're learning in lab will help you for lecture. It just doesn't seem like that, and you're so overwhelmed in the beginning, you're like, yeah, whatever, okay? But just letting you know, and you will see the light at the end of the tunnel by the time you get into 228. 228 seems like, oh, this is so much easier already. And I'm like, it's just because your brain and the way you think has changed, okay? So we try to teach you how to look at things differently. So that was the course policies. Read through it yourself, ask questions. Let's see. Also, you can find general articles. You can find 227 information there. You can also access things from the website on the bottom as well. So if you can't find something one way, there's lots of different ways in this website, lots of different breadcrumb trails. Let's see. Let me go over, what else can I tell you? So I told you about, so that's what we mean by point economics also, if you read the article on that. What we're talking about is if you have a 5-point eval in lab, and in the same week you have a lecture exam, what do you think is more important, 100 points or 5 points? 100 points. Do you think your lab instructor thinks you're an idiot because you bomb a lab eval? No. We don't look at you and go, oh my gosh, you don't know anything? No, we think, oh, it's exam week, isn't it? Okay, but keep in mind, you want to keep your lab grade up because guess what? 225 points is like a nice cushion. That's 2 1/4 exams, right? So don't let lab totally go by the wayside. That is not what I'm saying with point economics. What I'm saying is manage your time, manage your valuable time that you have to do things. What should you be studying for? Don't let lecture slip by. Okay. All right, we did that. Okay. I think I covered everything. I hope so. That was kind of fast, right? So maybe we can dive into notes now, right? Oh, blank notes if you want to find those. So I believe if you go into the OneNote thing here, I think those are the updated notes. So as I'm adding notes to the outline notes, you could go in and see them there. But if you're watching the video, you're going to see, I'm going to be writing on the whiteboard over your notes, and you're going to see all of that as well. So. All right, notes are right here. Okay, so ideally what we say is print your notes off before you come to class so that you can just add to the notes. I've had students that just like to listen to what I'm saying and then they'll fill in the notes later. I don't know how well that works, but if it really works for you, by all means. Typically, though, you need to be active when you are taking notes. Okay, typing notes out does not make the same brain connection as physically handwriting the notes out, drawing the pictures, labeling things, that kind of thing, okay? So what I recommend is, as I'm talking, jot down some notes to yourself. Don't hesitate to go back and hear the video again to fill in where, you may have missed something. Maybe you zoned out. We've all had our days where we need a little more coffee than other days, that kind of thing, so. Okay, and so anatomy and physiology, I think it's a fun subject. Not all of you will think it's a fun subject. Some of you, it's a means to an end, but if you think of it as, okay, this may not be the most exciting part of A&P, but I think you guys will get more out of it if you're kind of like, hey, let's learn this stuff. Just saying. Okay, so anatomy and physiology. Anatomy is the study of structure or form, so it's basically the study of how things are built. And physiology, ology means the study of, so physiology is the study of function of body parts. So this is the study of how they actually work. Did I say that or am I sick and I think I repeated myself? Did I say built-in work? I hope so. Okay. So the functions associated with the heart, for example, are difficult to visualize because the physiology of something isn't always something you can see like with the naked eye, right? So visualizing how something works or what it does, but as you understand the structure, like how something is built and put together, how it this part works with that part, it makes it easier to understand the function of it, because there's a reason something was made the way that it was. And when things aren't in the typical way that it should be, they don't always function the right way, right? So sometimes we see pathology or disease when that happens, okay? So as you understand the structure of things, function will be easier to understand, and that's why we, especially here, like to study anatomy and physiology together. So some schools will study anatomy one semester and then physiology in the next semester. And so sometimes you're learning all the parts of things, but it doesn't make sense to you because you don't know why this was put with that one, because you didn't understand how it worked together. So that's why if we integrate it at the same time, it seems to make more sense that way. So with anatomy, these are ways to see how things are built. So we can look at the gross anatomy. So this is usually visible to the naked eye. So when you're up in lab and you're having an eval, it's about gross anatomy. It means you shouldn't be naming things that are a histological view because you can't see it without the next thing, which is a microscope. So this is visible to the naked eye. And I made a pun today because they're studying the eye in 228. So we did eye dissection today. It was pretty cool. And I didn't even know I was making a pun. I'm like, you can't see it with the naked eye. So this basically means vision isn't modified. We're not talking about, somebody needing to wear glasses or wearing contacts or something, but basically what can you see without an aid of other things, essentially. Microscopic anatomy. So this would be with the use of a microscope. And the microscope then would be a tool to study how something is built. Because again, when we're saying anatomy, we're in the grouping or subheading of anatomy. So these are an outline. And so everything that you see under B means these all have to do with anatomy. And what we said just a second ago is that means how things are built. The next section will be physiology, and it means how does something function or work then. So the nice thing is we've kind of already made this outline for you guys, which helps a lot. But sometimes we get stuck in the details. I want you guys to remember to pull back out and look at the title of that area. So when you're looking at the notes, it makes more sense again. So different things that they'll use with microscopic anatomy, they'll look at cytology, which is ology, meaning the study of, and cyto is cells, so that would be the study of cells. And then there's also histology. And some of you guys have heard from other people or you've realized that you're going to be doing histology drawings. So study of, and histo is the study of cells and how they make up tissues. So histology is essentially the study of tissues, because you're usually looking at a group of cells or what makes this cell different than that cell. So we're usually looking at tissue types. So that's with microscopic anatomy. We also have surface anatomy. So this is usually like superficial anatomical markings of the skin areas. So it's typically used extensively by healthcare providers. So as a chiropractor, you might look at the different heights of the pelvis. And that's something you can visually see with your eye. The pelvis is hidden, in a way, under the skin and some adipose and muscle and things like that. But you could see where it indents in, and then you could feel it with your hand and palpate it. Also, if somebody is going to draw some blood, they've got to have some land markings that they're looking for to know that they're hopefully going to hit the vein and not a nerve or something, right? So this would be commonly used in healthcare. And usually, or what they are using are surface features then. Try to write correctly for you. So surface features would be the landmarks that are covered up by the skin. So another example might be a suprasternal notch. Supra, these words are telling you things. Supra, above, sternal, so here's my sternum, here's that notch. So that might be something to tell somebody where they could do certain things, right? So that would be surface anatomy. Embryology, when we look at it as under the anatomy heading, this is looking at structural changes from conception to birth, okay? So structural, because structure with anatomy, right? Structural changes, I use the triangle sign, or you'll see that in chemistry. So triangle means change or changes from conception to birth. So this is the study of an embryo and from the anatomy perspective. So keep in mind, though, embryology would also have a physiological component to it also, right? So that's why I say, don't get so stuck in the details that you're like, this doesn't make any sense to me. Back up and look at what is the heading that it's under. In your mind, put the two back together, and then it'll be a little more clear when you're going, why? She said it was this over here, but she said it was that over there, okay? So with function, we're looking at physiology. So the focus is mainly on function at a molecular and cellular level of various organ systems. So for example, if we're looking at the renal physiology, what do you think we're talking about? Kidney function, yeah. And I abbreviate function FXN. You'll see that in chemistry also. So kidney function. How about neurophysiology? What do you think that's looking at? Nervous system function. See, I'm not trying to trick you. And if we look at cardiovascular physiology, this would be the function of the heart and BV for blood vessels, so BV, and also blood. And I know it seems silly, but I just abbreviate blood BLD because instead of writing the O's, I don't know why, but it's just a little faster when you're trying to write a bunch of notes. So cardiovascular physiology would be looking at the function, the physiology of the heart and the blood vessels and blood. And you're going to see in a little bit that blood is a tissue within those structures or organs, okay? If we look at the interrelationships of structure and function, okay, so this is where I was saying how some schools will teach just anatomy one semester and just physiology on another. So the idea is that if we look at the complementarity, that's a big word, right? Complementarity of structure and function together. So what we're saying is basically that structure complements function and function complements structure. One gives you an idea of what the other does. The other can also give you an idea, and they have to work together, even though you can look at the components separately. So structure complements function, and I'm going to put VV for, and vice versa, back and forth, right? So it makes sense to study A&P together because if you figure out how it's built, you'll understand how it works. And for example, if I were to draw this and this, and I could tell you one's a spoon and one's a fork. They have different functions, right? I can't really use a fork to get soup up. Even a hearty soup, it might be a little difficult. Depends how hearty it is, right? If it's like spaghetti, it might be a little hard to use just the spoon, okay? Because I don't have a spork here. It's just a spoon or just a fork. So you could tell, though, by those implements how you might use them and what makes sense, right? Not that you couldn't force something to do something else, but one thing, too, is when something doesn't work right, sometimes other things help take up the slack. Right? So it's not that something else couldn't. I could use a spoon for spaghetti, but it'd be a little tougher. Maybe I wouldn't have as long a lifespan, you know, if I'm having to work that much harder to get it done, but I could survive maybe, you know. So another example besides spoon and fork, we could also say bones. So when I say the word bones, right, you have an idea of what it looks like in your head, right? So let's say you have like a humerus or a femur, or you're going to bonk, you know, bam, bam on the head with something, right? So you got a bone, and you have an idea in your mind, the shape of it, the form of it, so you could tell the anatomy of it, right, the structure. But what do bones actually do for you? Support and movement and, right, protection. So the function of it is not the same as the structure. That's all we're trying to get you guys to think is back and forth on this. So bones, you could see, you know, structure and support and a couple other things that we listed, right? So that would be the physiology aspect of it. So if we look at interdependence among cells, so for example, you could have heart cells. I'm just going to abbreviate with a heart. And you could have lung cells, right? A heart cell has a different function than a lung cell. It probably looks a little different. It might have some similar features because it's a cell, but they are different, right? So we are a multicellular organism, meaning we have lots of cells and lots of different cells. And I'm just going to do ORG for organism. And we have different organ systems that work together to promote the well-being of the entire body. So cells will specialize, which means they'll become more efficient at their job. If you have one thing that you do and that's all you do, you're probably going to be pretty good at it, right? Just do it day in and day out, over and over and over. Like the heart, pump, pump, pump. That's its job. That's all it does. But what happens if the heart stops? We're in big trouble. Who else does the heart's job, right? So if you have some cells that die, other cells might take up the slack, right? But again, as we specialize, we have to depend more on other cells or other organ systems to help us out. Yes? That's what it's talking about, the interdependence among cells. They become interdependent, but yet, and more efficient at one particular job, but yet they have to depend on another cell to take up and do the things that they're no longer so good at. So for example, if the pipes burst at my house and I need to call a plumber, would I call the chiropractor? It may not help very well unless it's a chiropractor that knows a lot about plumbing. And even then, okay, if my appendix bursts, do I want to go to the veterinarian? They might help in a pinch, but it's probably not the right specialist to go to, right? So that's where we, even in our own community, we specialize in our jobs and what we do and stuff. So we're multicellular beings that depend upon the proper functioning of each other. So multicellular organisms that depend upon the proper function of each other. Okay, and our cells specialize. And thus, because they specialize, it also causes them to be dependent on others, okay? So if we look at body levels of organization, okay. So this is set up, especially when it's saying organization, it's talking about a specific order or sequence. So if you look at chemical, this is going to be the simplest aspect, okay? So simplest. And if you go all the way down to organism, it becomes a lot more complex. So organism would be most complex. Okay? And it doesn't go backwards, it's just moving forward. So it's one direction, like the group. I don't listen to them, I'm just saying. So atoms, so for chemical, these are atoms formed to combine molecules and macromolecules. So for example, if you had one atom, and let's say it was equivalent or the same thing as one Lego block. So we have one Lego, that's one atom. If we stack 10 Legos on top of each other, that would be like 10 atoms. But we've made it a little more complicated. It's not a simple, tiny little thing like just an atom. Now we have a molecule because we have 10 of them linked together. And if we link a whole bunch more together, we might have a macromolecule, and so on and so forth, okay? So many molecules give you a macromolecule, and eventually you might have an organelle, which is inside of a cell. Organelle means like mini organ, so your cells have organs, essentially. Then if you have organelles, now you can get to the next level of organization, which would be cellular. So with cellular, the cell is the basic structure and functional unit of life. So cell is the basic structural and functional unit of life. That's important. Okay, so basically molecules would combine to form our cells. Okay, molecules combine to form our cells. So you can't say that a chemical is cellular. Okay, it's too small, it's too tiny. But you could say that a cell is molecular or chemical. okay, because it has those components within it. If we look at tissue, that's the next level up of complexity, right? So tissue is groups of similar cells that perform common functions. So in lab, for example, you're going to study, and also in lecture, you're going to study 4 tissue types. So we have 4 tissue types. We have epithelial, we have CT or connective tissue, we have muscle, and usually when I'm abbreviating muscle, I just put little m, so it means muscle. And then also we have nervous, so sometimes I'll put just an N for nervous, but I'll write it out this time. Okay, so of those, for example, if we looked at just muscle tissue, some of you may already be aware, but we actually have 3 types of muscle tissue. We have, anybody want to take a guess? Smooth muscle, skeletal muscle, and cardiac muscle. So can you guys see? They are all muscle, so they're similar tissue. They're going to look different histologically. So when you look at them under the microscope, they're going to have different organization about them. And once you understand that, it's really easy when you see one slide and versus the other, you'll be like, oh yeah, that's definitely skeletal muscle. Because you'll find certain landmarks, things that are about that type of cell or tissue that make sense. Okay. So again, these are all, if we talk about just muscle, they have a similar function. And what do you think muscle does? Movement. Yeah, so skeletal muscle, moving the skeleton to ambulate the body, right? Smooth muscle is moving things through hollow tubes, essentially, and organs. And then was the last one, cardiac, is to pump the blood and move that around, right? So this makes sense when you think about it. If we look at, and remember, cells aren't made of tissue, but tissues are made of cells, right? So that's what this is trying to get you to categorize the organization of something. So now if we look at an organ, so this is a group of 2 or more tissues forming a specific structure. So not just structure, but that also perform a specific function. And specific function. Okay. So for example, if you had the heart as an organ, right? And it's a very specific structure and it performs a very specific function. It is made of 2 or more tissues actually. So you have heart muscle cells or cardiac muscle, and you also have CT or connective tissue. Otherwise you just have a weird smear of cardiac cells and nothing holding them together, no scaffolding. So that's what the CT does for it. So you had 2 types of tissue, connective tissue and cardiac or muscle tissue, together that made an organ. And then if we look at a system, so this is 2 or more organs working toward a common goal. So for example, you could talk about the cardiovascular system, right? So what you're saying there is you're talking about heart and BV or blood vessels. And they have to work together, and that's what creates a system, okay? So all of these systems functioning together then would end up giving us an organism, which we said was the most complex part of this. So this is the highest level of structural organization. Highest level of structural organization. And so, again, think about it this way, is a cell an organism? Not in our case, no. Okay, is an organism made up of cells though? Yes. Okay, so what they're showing you in this picture here is these components here would be part of the chemical organization. So you start with an atom, put a couple atoms together, you end up with a molecule. You can get larger molecules like DNA, and then you end up with cellular components or macromolecules or organelles. Then you end up with a cell. Okay, so that would be one level up on the organization. Then you end up with a tissue. Then you have an organ, then you have a system where 2 or more tissues are working together, and eventually you have a human being or organism, right? In this case, we're talking about us. So if we look at characteristics of living things, okay, so these are things that we will need to survive in an environment or any environment. Okay, so these are necessary life functions, things we need. I love having a squeaky voice to function in any environment. Okay, so for example, with maintaining boundaries, so this is keeping internal environment separate from an external environment. So what do you think is a big thing that does that for us? Skin, right? It's a barrier. Outside world, preventing it from getting to the inside world, essentially. Okay. If you were looking at it not on an organismal level, but let's say on a cellular level, what might be the barrier or the boundary? A cell or plasma membrane, right, for the cell. So I'm going to put here skin, if you were talking about the organism, but also if we were looking on a cellular level, you could say plasma membrane. For movement, let's see, what else do I want to say? Oh, so skin or the integumentary system, which is talking about skin, does this on a system level, and the boundary we have for cells. So for example, do you want things leaking out of cells that produce stomach acid, getting to other parts of your body that shouldn't have stomach acid? No, so that's kind of like what the whole plasma membrane thing is, okay? With movement, so these are all activities caused by muscles. And so we said that we had 3 muscle types, right? Skeletal, cardiac, and smooth. We have to have responsiveness. So this is sensing changes in the environment. So this could be excitability or having to do with our nervous system, right? We need to sense if, you know, that's hot, get off, you know, don't touch the stove. Or should you stand there with your hand hanging on to it? Not good, right? So excitability. So this is nervous system. Digestion, so breaking down food into molecules that your cells can use. And we really get into digestion a lot when we do 228 material next semester. But this is your, you know, we're really creative here, digestive system. So that's digestive. You might also see it as GI or gastrointestinal, right? Now with metabolism, it's not really a specific system, if you will, but because all of our organ systems have their own metabolism, that's why we put this in here also. And metabolism is the sum of all chemical reactions of the body. And what that means is all the build-up reactions and all the breakdown reactions. And what do you think is happening with a breakdown reaction, for example? You're taking like a macromolecule or something large and breaking it down to something small. So I could take a potato chip and chew it up and break it up, but I also have digestive enzymes that can break it up even smaller, and eventually I will get it small enough that my cells can absorb those specific nutrients that I might need. If I had to build up reactions, let's say I ate way too many potato chips, and I have decided that I can't use that energy right at this moment, so I'm going to store it. So I will pack it away into other larger molecules. So I've broken it down into teeny tiny stuff. That was the breakdown side of it. But now I have all this teeny tiny stuff floating around, and I don't need it right now. I'm going to go to sleep. So I need to store it away for later use. So I pack it away and make like triglycerides out of it and pack it away for later storage of energy. So that would be like a buildup reaction. So those are your 2 types of chemical reactions. So basically with breakdown, you're going to say big molecules get broken down into smaller molecules or its building blocks, right? Kind of like the Lego thing. So for example, like the potato chip, that starch would be a big molecule, right? And then it gets broken down into sugar essentially, or glucose. Okay, and that is something that I can utilize and store for later for energy. And so if I am breaking things down, this is called a catabolic reaction or catabolism. So this is catabolic. And the way you can remember it is cats chew things up, break it down, right? Chew on cardboard boxes and toys and birds and whatever else, right? So if you're building something larger, so this would be small molecules that get made into bigger molecules. So for example, if you had a small molecule like an amino acid, that would be a building block, right? AA for amino acid. And it could be put together, linking a whole bunch of amino acids together would end up giving you a larger molecule called a protein, right? And this kind of reaction would be called anabolic or anabolism. So one thing you could remember is, what are bodybuilders trying to do at the gym? Build muscle, right? Bodybuilder, muscle, gym, right? Usually. So some of them, not all of them, some of them might be on anabolic steroids to build muscle faster, right? So anabolism, build bigger. You can remember anabolism is building, catabolism, chewing it up, breaking it down. That's an easy way. These are the kind of things that you want to try to associate so that it's easier to recall this stuff when you're on an exam and you're like, I don't know what anabolism is or anabolic. So all of the catabolic reactions plus all of the anabolic reactions gives you that organism's metabolism. That's what that's saying, okay? Alrighty, let's see. Other things that we need to do to survive in any environment. Well, we have to get rid of waste products, so that's excretion. And the main system that we will use to do that will be through our urine, so the renal system. And if someone was in renal failure, for example, other things have to take up the slack and help you out. And oftentimes that might be through the integumentary system or the skin. So because they can't get their waste products out one way, it starts coming out of the skin. So sometimes people having issues such as renal failure might have a different or funny, not so great smell about them. If you've worked in healthcare, you will smell all kinds of wonderful smells. Gangrene is probably the worst. Just got to say. There's no getting that out of your nose. Alrighty, so also sometimes through the respiratory system, we will off-gas things, breathe out other gases. So sometimes a diabetic might smell fruity, right? Because they're in acidosis, right? So other systems are trying to take over to get the waste out or to help get you back into a homeostasis or a normalization or normalized being, if you will. Reproduction. So this is producing offspring. So that would be your reproductive system. So I'm just going to put repro system. Okay, because if you can't reproduce as a species, then your species is going to die out. That's not good. And then growth also is not really a system, but this is increase in organ or body size. This is usually by an increase in cell number, not cell size. Okay. So you could think of like babies or kids growing up. All right. Obviously, they have to have more cells to get from teeny tiny to us, right? If we look at survival needs, these would be things that come from the environment in order for you to survive. So it's a little different than necessary life functions and how systems have to work, but now we have to feed this thing and water it and make it grow, right? So these would be like nutrients. So the main categories under our nutrients are carbohydrates, protein, and fat. Nutrients are chemicals for fuel or energy. You're going to hear us talk about an energy molecule called ATP or adenosine triphosphate. And you'll hear it now, and you're going to hear it more in 228. And so these nutrients are building blocks for growth and repair also. Okay. Because if you cut yourself or harm yourself or something's not functioning well, you got to help fix it, right? So carbohydrates are our body's main fuel. Okay. So your body prefers carbohydrates as a fuel, probably why we crave them when, we're stressed or whatever. Proteins are building blocks for new structures as well as replacement structures. So protein is, that's why, sometimes older folks, when they're not getting a proper diet, not enough protein in their diet, they can't heal and repair because they're not eating or something like that. So that's why you're seeing people doing more of those protein shakes and that type of thing. So building blocks for new structures and replacement structures. All right, and then fats. This is energy storage and also some building material for our cells. Energy storage and some building, but it's more the protein stuff in general. Building materials for our cells. So the reason I'm saying for our cells, so some of you guys might be a little familiar if you've had a biology class before. What is your cell membrane made out of, or your plasma membrane? It's a phospholipid bilayer. Lipids are fat. So you guys might be too young, but Garfield used to have a poster and it's like, you are what you eat. So depending on what fats you're incorporating in your diet will depend on the fats that are making up your cell membranes of all the cells of your body. So it does make a difference. So if you're eating a whole bunch of trans fats, you're putting a whole bunch of trans fats into your cell membranes, they're not going to be as pliable, so on and so forth. So it does help with building materials as far as the cells. We need to be able to breathe, so we need some oxygen, which is required to burn fuel, which means for ATP production, basically. So we call those oxidative reactions. Oxidative reactions, okay. And for water, the most abundant substance in the body, it actually makes up about 50 to 60% of our body weight is water. And why do you think there's a range? A little bit more like an elderly person versus a baby. So an elderly person, and a lot of times you'll see them, if you've had to take blood from them and their veins roll and they're not well hydrated and it's difficult to get blood from them, versus like a newborn baby is super plump and moist, and that's a weird word, isn't it? Moist. So depending on, age range and what you're doing that time of your life, are you keeping well hydrated? So there's going to be a fluctuation as well as a range of, when you're very, very young, you're going to be a lot more fluid filled, higher percentage of body weight is water. And as we get older, we tend to have a little less. And let's see, also required for and produced by chemical reactions. So required for metabolic reactions. Required for metabolic reactions. So when we were talking about catabolism or anabolism breakdown and building reactions, right? So for example, catabolism also could be since it's a breakdown, it would be a hydrolysis, lysis to break up, hydro using water. So those reactions don't necessarily mean you took one water molecule and cleaved this molecule into two, but essentially that's what's happening. You end up taking an H from the HOH or H2O, goes on one side of a molecule that you broke apart, and the OH goes on to the other. That's what you're really seeing. And if you were to bring two other molecules together and fuse them together, if you will, or bond them together, you could do a dehydration synthesis. And doesn't dehydration sound like water, right? So you actually are producing water or removing water from that molecule. That's why it's called the dehydration synthesis, because you're building a molecule. So that would be a anabolic reaction, right? So use this terminology and apply it back and forth so that you're comfortable realizing. So we introduce a term over here and then we use it again over here. And you want to go back and forth and go, oh, that's why that makes sense. That's why she talked about building a molecule here. And that's a reaction like this over there. Because we're going to talk about dehydration synthesis and hydrolysis in the chemical chapter also. So. And let's see, how about body temperature? So we must maintain at 37 degrees Celsius, which is AKA, if you will, 98.6 degrees Fahrenheit. Okay, so if you're too cold, what do you think happens to chemical reactions in your body? Slows down. And if you're too hot, what do you think happens? Speeds them up. So I just saw a thing. It was like, on the Weather Channel app, and you pull it up and they show you like crazy weird weather stuff, and it was showing these, I think it was alligators or crocodiles, I'm not sure which. So it was so cold that it's frozen, so they have their snout just sticking out of the frozen water, and their body metabolism is so low, they're essentially hibernating until things warm up. So it looks like they're dead because they're just laying with their snout sticking out of the ice. But that's what this is talking about, right? But what about too hot? I mean, you could die from either one potentially, yes. So what do you think is happening if you heat something up too much? What happens when you crack an egg and you put it in a hot pan? And that white, that clear stuff turns what? White, right? That's protein. That's the protein part. That's albumin, okay? So if you cooked that egg, that part of the egg, the albumin, can you get it back the other way? What do you think is happening to the proteins in your body when you run a fever for too long of 105 or 106? You're damaging things. You're breaking down proteins. You're breaking stuff down. You sped up reactions and you're breaking things down. And it may not come back. And you might have permanent damage or death, right? So that's what we're talking here. So enzymes are proteins, and sometimes you're breaking down your enzymes. If you don't have an enzyme to help facilitate certain reactions in the body because you broke that down, you can't have other functions happen in the body, and then, right? Okay. Maintaining body temperature is mostly due to your skeletal muscle, all right? Probably why gentlemen tend to not be cold all the time and women are, because men have, in general, more muscle mass than females. Not always. You could have a female bodybuilder and you could have a very petite male. It's possible, right? But in general, when we're talking about something like that, we're talking about in the general population, males will have more muscle mass than females. Okay, so mostly due to skeletal muscle, MM. What else do I want to tell you? I think I skipped around in my notes here. Let's see. Let me double check. So body heat is mainly generated by skeletal muscle. So what happens when you're cold? You start shivering. It's little motions with your for your skeletal muscle, right? And then the last one with atmospheric pressure. So this is required to move respiratory gases. Okay, so basically this is absolutely necessary. We have to have a certain atmospheric pressure in order to move air or gas into and out of our lungs. So you really get an appreciation for that in 228 when we go through the respiratory system and you understand how the diaphragm and negative pressure works within your body and that type of thing. But so for example, like in high altitude up in the mountains, not so much gas, like thin air, you know, when they say that term, thin air, okay? So let's stop just a little early because I'm going to show you guys how we're going to do a clicker. Even if you're not registered or whatever, you can still use your clicker if you have it. This is just kind of more of a practice today. So we'll meet again on Thursday at 1 p.m. and you guys have lab on Thursday or Friday. So just bring your stuff with you. They will get you logged into Connect on your first lab. Okay, so don't stress about lab stuff. And let me pause this.